Hello everyone, my name is Benjamin Martinez and today we're going to be doing a coffee cup calorimeter problem. So to begin, let's start by drawing off our coffee cup calorimeter. So I'll use white for our cup. So we have a cup here. Oops, sorry for my shaky hands. Let's put some water in there. And then we have our calorimeter. So this is going to be like a temperature stick. And then inside we have NaOH, our reactant. So we have inside we have our products. So we have NaCl and H2O. And outside, what went into it was HCl. This is what was mixed. And we have NaOH. Okay. So exactly how much NaOH? So we have 50 milliliters of NaOH and we have 50 milliliters of HCl. And the molarity for HCl is 2 and the molarity for NaOH is 1.5. And this is all given right here. All right. Next, let's just write down what we're given. So we're given exactly 150 grams of H2O. I like starting off these problems by just writing off everything we're given. Our T initial is 22 degrees Celsius. And with that, we'll also have a T final. And if we look down here, we have our T final of 28.4 degrees Celsius. We have our specific heat of the solution. So this is the solution and the cup temperature. So we can just put heat equals 4.18 joules per gram times degrees Celsius. And the density of our solution is 1.00 grams per milliliter. All right, so now that we got all this, we need to find our limiting region. So our number one, let's find limiting region. And to find our limiting region, we have to multiply our volume times molarity for each one of these. So volume times molarity. And if it's not already in liters, then we have to transfer it into liters. So let's do 50 milliliters. Let me do a different color actually. Let's do pink. So we have 50 milliliters. And this, let's start off by doing HCl. So we have 50 milliliters of HCl. We have to turn this into liters. So for every 1 liter, we have 1,000 milliliters. So we can multiply this and we get 0.0500 liters. And now that we have this in liters, we can multiply this by our molarity. So our molarity of HCl is 2.00. And then we get 0.100. And that is moles. So now that we have the moles of HCl, let's get our moles of NaOH. So the same thing. NaOH. We have 50 milliliters as well of NaOH times 1 liter. 1 liter for every 1,000 milliliters. And that equals 0.0500 liters. Let's times that by our molarity. So our molarity is 1.5 molarity for NaOH. And that gives us 0.075 moles. So now that we have the moles, we can look back at our reaction and we could see that is 1 to 1. So because it is 1 to 1, we can automatically assume that the limiting region is the lower number. And the lower number in this instance is NaOH. So NaOH will be our limiting region for this question. So now that we have that, let's move on to what we have to do next. And so now that we have now that we have that the limiting region is NaOH, let's calculate the mass of the solution. So we're given early on right here that 50 milliliters of HCl, and then we have 50 milliliters of NaOH. So we can now, let me write number 2, calculate mass of Sol. Okay, so we were given 50 milliliters of each of these things that were mixed into the solution. So of our solution of these two, we have 50 ml plus 50 ml equals 100 ml. And we will have to transfer this into grams. So because our density is 1.0 g-mole, we can just transfer this directly into grams. So 100 grams. So now we have our grams. We have the mass of our solution. Let's move on to what we need to do next. I have to go into a new page. Now we must calculate delta T. Calculate delta T. Okay. And so to calculate delta T, we must subtract our T final from our T initial. So right here we have our T final, which is 28.4 degrees Celsius, and our T initial that we were given in our problem. Both of these we were given in our problem, and we have T initial as 22 degrees Celsius. So let's do that, 28.4 degrees Celsius. Let me make sure, yep. Minus 22 degrees Celsius equals 6.4 degrees Celsius. So this is our delta T, equals delta T. Now our next step will be to calculate Q. So now that we calculated delta T and we've gotten 6.4 degrees Celsius, now we will go on to our next step and calculate Q. So to calculate Q, we will put the formula Q equals MC delta T equals, so let's put our M. So our M is 100.0 grams. So this is the mass of the solution times the density that we were given, 4.1, or sorry, not the density, the heat of the solution times the heat of the solution, which is 4.18 joules divided by grams times degrees Celsius, times our delta T, which is 6.4 degrees Celsius. And then I'm going to have to bring this down here for our answer. So we get, when we calculate that all up, we get 2,675 joules. And we must transfer this into kilojoules. And so before I go any further, we must also cancel out our units. So when we do this multiplication, we use grams here, here, and we use Celsius here and here. So that is why whenever we solve, we are left with this joules here. Let me do this in different colors. So that's why this joules is brought here. And we must transfer this into kilojoules. So let's do 2,675 joules times 1,000 joules for every 1 kJ. That is the measurement for this. So let's do that, and that gives us 2.675 kilojoules. So now that we're left with our kilojoules, we can now finally calculate for our final step. Let me put our final step here. So calculate delta H per mole using our limiting region. So let me go back. And so we've already calculated our limiting region. We have this one right here, NaOH, which is our 0.075 moles. And we have here our kilojoules. So to calculate delta H, let me put the formula here. Let me write it in pink. Delta H equals negative Q, which this is our Q because we solved for Q, so this is Q. So our kilojoules number here divided by our LR, limiting region, equals, let's plug in these numbers. So we have, put this in red, 2.675 kilojoules divided by our LR, which is 0.075. You make sure. Yes, 0.075 moles, which equals out to be negative 35.7 kilojoules, because none of the units cancel out. We bring all of our units down. Negative 35.7 kilojoules divided by moles. And this is our answer. So here we're asked to find our Q. We found our Q. And then we're asked to find delta H. And we also had to begin by finding our limiting region to solve for this coffee cup calorimeter problem. So thank you guys for watching. I will be moving on to my next question, and we'll be going on from there. So let's do that, guys.